Mickey McManus. Hi. I'm a senior advisor at a place called Boston Consulting Group, BCG, and I ran a design lab and an innovation lab called Maya that came out of Carnegie Mellon about 30 years ago. And I was also a fellow at Autodesk in the office of the CTO exploring generative design, which we'll talk about today, and generative learning, which accelerates human learning using machines.
And I'm Heike. I'm originally from Stuttgart. I'm in San Francisco now. And also industrial design background. Both of us studied that in Illinois. I was at Autodesk, have been at SAP. I'm doing design consulting, so to speak. It's fascinating that a lot of you, I think design thinking, that we'll talk about today, it seems like a lot of you coming from the creative space. I'm sure you've heard about it. I'm sure you know a lot about it, but we'll go through that today, just the origins, what is it, why is it important? And then we'll go into generative design and generative learning, because that is really fascinating. That's something new. As I mentioned, we're going to talk about design thinking. So what is it? Tim Brown, I'm sure everyone knows IDEO. He talked about it in the term of a human-centered approach to innovation that draws from the designer's toolkit to integrate the needs of people, possibilities of technology, and requirements for business success. I think here what is important is really the triumvirate, the triad of people, technology, and business success. So that's why IDEO is also saying thinking like a designer can transform the way organizations develop product, services, processes, and strategy. And actually, I think Mickey and I, we would say it's not can, but they do transform the way organizations work and really lead to success. So the origins of design thinking. We know, especially, as Europeans here as well, so the Industrial Revolution and World War II, they really advanced technology. And during that time, when technology has developed new skills and new possibilities, the engineers, architects, and industrial designers, also cognitive scientists, began collective problem solving. So there you could see that really the strength of interdisciplinary teams started at around that time. And design thinking, the term was mentioned for the first time by Herb Simon in his book, The Sciences of the Artificial. Sorry, people, I want to see your faces. Who has read the book? Who knows about it? Hands up.
I think there might be a way to see, we'll go this way. We're just going to try to see your faces a little bit.
Yes, exactly.
And yeah, there we go.
Yeah, everyone's here. Okay, put you to the side. So has anyone heard of of Herb Simon? Okay, so in your free time, you can read about it. But what he said, design thinking was a body of intellectually tough, analytic, partly formalizable, partly empirical, teachable doctrine about the design process. A little bit wordy. We'll get into it a little bit easier. But something that I like also to talk about for Herb Simon, what is design? I know you met with some designers yesterday, but I think a really good definition of what design is to devise courses of action aimed at changing existing situations into preferred ones. So it is a broad definition, but it is good. All right. So that's a little bit about the origins of design thinking. We also know then after Herb Simon came up with it in the 60s, 70s, then IDEO actually picked it up in, I want to say, around 1990s. And then 2005, Stanford D School was founded. That was actually funded by Hasso Plattner of SAP. And so D School has really been doing a lot of training around design thinking and why it's important, what it does. They have a lot of methodologies. They also have a lot of free tools. So yeah, being here in San Francisco, we are exposed to that a lot. Okay.
Can I go to the next slide?
Yeah. Then I will take people away. So design thinking, and actually what I like to say, Mickey, you too, and Hartmut Esslinger, Frog Design. Design thinking in a way is a marketing term that IDEO has done a fine job of really building out, but we're more of the notion of design doing. Right, so let's not think about design, let's do design. And in the context of a design process, the world has become increasingly interconnected and complex. So we can't use old approaches anymore to come up with solutions. And so design thinking quotation marks or design doing really offers a human-centric approach to reframe or solve wicked problems. And do you want to say a little bit about the complex nature of the world? Did you write a book about it?
I did.
Maybe?
I wrote a book called Trillions, which if you're really interested in understanding kind of what happens when we have trillions of computational machines and we have to actually think about it from a design standpoint, it turns out you can learn a lot from nature. So a major chapter in my book was about biomimicry for information systems and how we can actually look at nature to learn the design patterns in nature that can actually help us cope with this. You know, but I think at the core of this whole idea of design thinking and design doing is putting people first and trying to discover unmet or unvoiced needs so that you can build superpowers. You can help basically extend people's reach. And I think that's really where we want to go with it. It's just that it's complicated and the solutions are not in any one discipline. And so design happens to be a powerful tool to get interdisciplinary and anti-disciplinary thinking, where you really recognize how to be humble and put your own sort of ego aside, and you really look for who the need knowers are and who are the actual stakeholders that can do things.
Mm-hmm. Thank you. All righty. So going back to a design process, empathizing, again, what Miki also said, it's all about the user. Who is that person? Who is your customer? Who's the end user? How can you find out what their unmet needs and desires are? Because even when you ask people, when you do, focus groups, maybe they will tell you what you want to hear in essence, but it's not the same as really observing them when they're doing the work. Defining what you want to solve is also very important, because as we know, if we can't really define and put that framework around what we're trying to solve, it becomes difficult. And then going into divergent thinking, where you ideate, you go out, and then going into convergent thinking, where you come down into, okay, what are we going to build now? What are we going to prototype? How will we iterate? It's prototyping, and then obviously testing and doing it all over again. Why is this important? You might ask. Because, click, design works, we know. So design-centric companies, we know they have outperformed the Standards & Poor's 500 index. So really you get a better return of your investment, which was in the happy days of 2015. Hopefully that'll pick up that upward line again.
Well, you know, the interesting thing is, while technologies might evolve really fast and business models evolve a little slower, humans take, tens of thousands, if not hundreds of thousands of years to evolve. So if we put people first, we've got this stable place where we can actually understand their goals, their desires, their unmet needs. And if you can put people first, you can usually find that most products are very technology first and basically assume the user will figure it out. And while users are pretty sharp, we shouldn't be making them solve all of our problems. That's just bad design. And so you can actually just, by putting people first, you can really outperform others because they're stable, and humans' ways of thinking don't actually change that fast. It takes time over culture.
Mm-hmm. So now the design process, a nod to the design process. As you can see, it's highly scientific here, but it might be the emotional spectrum where you go up and down, and you said photography, you have ad agency. So, it's at first, until we really define what it is, when we do research, when we have to go in there, there's a lot that takes place until we get to concept. And then eventually when things calm down, we can get to design. A little bit of a different frame is we talked about the 5 stages, or you've seen them earlier, but I think something that is important to note, that I'm sure a lot of us know as well, this is not linear. This goes in all sorts of places. You might start to empathize right into the prototype. Prototype could give you information about ideation, into definition. So it all kind of happens at once. So no process really is linear.
I think it's worth noting, when you're sort of an amateur and you're just starting out and getting into design, or you're trying to understand how to weave together different points of view, you tend to follow sort of recipes and sort of tricks of the trade, best practices, and those are useful. But when you meet someone who's been sort of a life of design, who's gone into not only design but gotten advanced degrees and worked in the field, you find that they're a little bit more like jazz. You know, they're taking a little bit of this tune and then they're mixing it up and then they're riffing on it and they're improvising. And that's really how the process typically feels. It's a little bit more like jazz in some ways, just because you're building on each other's thing, but you have to learn how to listen, and then you have to learn how to like play with what people come up with. And so often what people say their problem is, their exposed sort of stated symptoms are not really the problem. And you've got to kind of riff around a little bit until you find out what the real cause or the underlying thing is. And that's why I think this is a great way to think of it. It's just, it's pretty improvisational.
Mm-hmm. I think we'll pick up on that theme. Here we go. Concept to implementation journey, again, a little bit of a different way of looking at it again, but whoops, oh, that's good. The 3 phases: ideation, design, delivery. That holds true for most everything that we designers do. But again, so from concept to production, always understanding the user needs, designing, giving form or gestalt or shape to a solution, and then lastly, plan and build the product. And what is important about this is the question, are we making the right thing? That's when we ask, when we're closer to concept, as we're going through that convergent thinking, you know, is it the right thing? Eventually, when we get closer to production, is, are we making the thing right? Right? Because first, is it the right thing? Do people really need this? Is there a use for it? Does it provide, is it usable? Is it delightful? And then are we making it in the right way? Is it more from business operations as well? Is it efficient? Is it production methods? How do we distribute? This is an important one in this context, because if you don't do your planning right, it becomes difficult. You can see here, relative cost to repair, right? So involving users throughout design and development is crucial for success and cost effectiveness. Because if you think, oh, we're just going to do something and we're going to launch it, and, you know, our engineers are fabulous, they can just throw something together, it becomes really, really difficult to redo it in the end. And I think every company where we've been, we've seen this a lot. And especially when you think, software design, you know, that's easy to do, we can fix it later. No, it really becomes difficult. So just do your research upfront, involve the users, and always do this, keep the users in there. You don't have to do big ethnographic studies and, you know, spend gazillions of dollars on it, but always make sure you check with them that you can get that intelligence to build the right thing and not spend 100 times of the original cost to fix it later.
I think a lot of times we see people do some kind of design research at the front of a project. And they'll sort of go, oh yeah, no, we listened, this is what we heard. And then they'll disappear into their sort of agile or their development methods, and they'll start producing things really quick. And then they kind of force the user to deal with all of their bad design decisions, because they don't really keep inviting the user back in. And if they use more of a successive approximation approach, where they're just touching the stakeholder more often through the process, they would be nudging themselves kind of in the right direction, instead of sort of one time getting insights and going. I often see people misunderstanding market research versus design or ethnographic research. If you think of market research, you take 1,000 people and you get maybe 5 insights, and it's mostly people talking about their best day. But if you take design or ethnographic research, you might take only 10 people, but you'll find hundreds of things. You'll find all these little nuggets of places where they fall off a cliff in between a particular project and in between what they're trying to do, and they jump out of your tool or out of your program and they solve it themselves. And if you don't study what they do there, you'll never get it. You'll miss what they're doing.
Mm-hmm. Yeah, good point.
Go to that collapse.
A tiny bit, yeah. But I like to see one person at least. Okay. Sorry. So this is also interesting, because we all know Agile, right? And now how do we compare human-centered design principles to Agile values? So the top row is human-centered design, as you might say: understand and involve users, advance iteratively, driven by evaluation, collaborate across disciplines. We had mentioned all of this already. Below then is Agile, customer collaboration, working software, responding to change, individuals' interactions. And here it's interesting, because the first row, if we go back to doing the right thing, we could say that this is the first row as we design it. And then when we do Agile, it's doing things right. So this is a nice overview here. All right, continuing with designerly activities. So what do designers do? A lot of you know this as well. As we are looking at each phase, there are a myriad of activities that we do because, again, empathizing, you know, the research notion. How do we define it? Personas, role objectives, decisions. What are the pain points? What are we trying to solve? What's the customer, the end-to-end journey, right? So millions of ways. Ideation, which to a designer is always wonderful. Abductive thinking means what could be. So as we go through what could be, what could this field look like? Eventually also then arriving at we'd like to do the importance difficulty matrix. Okay, you know, we have great ideas. How important is it? How difficult is it to make? And then eventually we get into prototyping. So mock-ups, storyboards, storytelling, hugely important. That you also get that visceral reaction for investors as well. So when you have an idea, and it could even be a sketch, but to show what you're thinking and to, you know, that you can feel it. You can do paper prototypes, you could do anything, but again, showing your story cohesively and storytelling again. And then eventually when you build it, you test it, and you go through this, as we've seen, not linearly, but all over the shop.
I think it turns out the storytelling is really important. You know, often you'll use what they call a Wizard of Oz prototype. You're sort of the wizard behind the curtains pulling levers, but you make a prototype work without writing all the code, without building all the physical things. You can do this with autonomous vehicles. I've seen this done very well with hospital situations, with massive systems. And you basically prototype first, but the storytelling allows you to actually say, what's the narrative? How do we go from the world that we're in today to the future world? And how do we actually believe in it when we have to kind of spin up the flywheel for this new business or this new approach? So that turns out to be very powerful.
Yeah. So of designerly activities, I also want to do a nod to the Luma Institute. Vicky knows this well. That was when we were at Autodesk. We started at it. So it says, you know, design thinking skills, live and online. So again, if you're bored, you can, so now you have a book to read. The Herb Simon one, and if you want to also participate in this, because really wonderful activities, and it's not just for design projects per se, but really figuring out a business's futures. And do you want to say?
I'd say Luma? One or two things about Luma. Luma's around the world. We've taught probably about 80,000 people, and I say we only because I was running the Maya fund when we funded this, so I was one of the early investors and helped kind of get it going. But it's around the world, and Autodesk chose, unrelated to me being involved in it in any way, Autodesk chose to train up a number of their people. They turned it into a movement inside of the organization. So if you think Autodesk makes the software that most people use to design the physical world and also the world in Hollywood and the digital world for gaming, they've got about 10,000 employees, and more than 1,500 of their employees are certified Luma. And so I was recently talking to one of their advanced research teams, and they did a 2-day offsite, but because they all had been trained up and they turned it into a movement of kind of just putting a little bit of people first and design and iterating, they actually ran an offsite for 2 days around the world, and it was like a normal offsite. They were just like, well, we just didn't spend as much money on tickets, on plane tickets and stuff, but we ended up having some of the best engagement ever because we were virtual, but we weren't looking at people's faces. We were actually working together on whiteboards that were virtual, and we were working on with tools. So Luma's one approach where people tend to kind of build their own muscle around it by doing things. There's something called the Luma Workplace within Luma that has a bunch of online tools and tutorials and templates.
Yeah. And I think, so why we're mentioning this as well, because we think we might have to work virtually for a little bit longer. And we're really looking at I
just wanted to see what.
No, it's fine.
This,
so what tools do we have in the chat? Oh, there it is. Thank you.
Okay.
Yeah. So what tools we have that we could use to virtually do the creative activities, and again, to get a framework that we all understand to be able to drive business forward. All right. Now we will go to the next portion of this presentation, generative design. Who of you knows Autodesk? I just want to, you can use your.
Raise your hand.
Oh, most of you. Niki, ich
So a few
weiß.
people.
Okay, so a few people know. Okay, so Autodesk is a software company that was founded in San Francisco 38, 39 years ago, 5 guys. And it really is the software, 3D software that is used to make anything. And when I was at Autodesk, I was actually doing creative direction and brand strategy as well. So we came up with this whole new, the branding, I love the old brand strategy. We also came up with a tagline, right? Which is, we know, very difficult, but really we are, I still say we, the make anything company. As Miki mentioned, it is from infrastructure to roads to products to media and entertainment, the last 20 Oscar winning movies for special effects, all using Autodesk. And someone said that we're almost the best kept secret in the industry because not too many people know about it.
Yeah, I think something like 80% of all the skyscrapers in the world and most of the cities and most of the factories are designed in Autodesk software, something like Revit or InfraWorks, most of the bridges and,
Yeah.
and core things. And then, yeah, we've won an Oscar more than, I think, 30 years in a row because just about all special effects and video games and things like that are made within something like Maya or Flame or Flint.
Mm-hmm. So this is Autodesk, and just to show you, so we have loads of products. I'm not going to go through the business model change, but you can see, I mean, it's really, fascinating, powerful tools. AutoCAD, you probably know, I worked with it ages ago, but it takes about 4 years to really master the tool. So this is not just in and out that you can play around with it, but it's really powerful stuff, again, how the world is built. And why this is important.
We visit the gallery in every tour. So when we have an on-site tour, the Autodesk gallery is a must stop, and Marcus and Maren have been there as well.
Yeah.
So Heike was responsible for the Autodesk gallery. If you ever went there, that whole experience was her team.
Yeah, and why the Autodesk gallery works so well, because it's a good point, because again, it gives you that visceral feeling, because it's a showcase of what our customers have created with the Autodesk software. So it's the Shanghai Tower, it's a molecule, a protein that was built, it is prosthetics, it ranges the entire space, or even a Mercedes, they did a biome car, a car that could grow out of a seed that you can't eat, but it would, biodegradable. So anyway, so conceptual work and real life projects. Yeah, actually the gallery closed, well, for at least a year now. They're redoing it. And then I was working on a virtual reality gallery already, because can we scale that experience? But, I'm diverging slightly, but that's Autodesk. Alrighty, Autodesk, doing a lot of research and always trying to come up with new ways to approach a project. So this is Autodesk University, 10,000 people converging in Las Vegas. It used to be an annual event in person. God, it's so weird, isn't it, now to look at all those people as they're sitting that closely together. But anyway, hopefully we can get there again.
I think we'll sit together again.
I hope we can sit together without face masks. But so Autodesk coming together, and what is fascinating about this is we do it every year. And we thought, how could we approach it differently that it becomes even more effective and even better experience for the attendees? And what we did was we used generative design. And what generative design is, goal-driven design. So you enter your parameters of what you want your design, what it should address, what it should come out with. So in our case, we said buzz is super important and exposure. So how can we create the best floor plan that people have this experience where, the buzzworthy stuff is close together and that they're exposed to it in the right way. So on the right, you see, or no, actually here. So this is, the computer spits out hundreds of possibilities. And then we had to go through and decide, okay, do we want to do this or this or this based on the floor plan in Las Vegas? And we ended up doing this design, which I still think looks a little bit like a old village, right? It might have been the church in the center, but where every star, it radiates out. And this is not a floor plan that in the old days we would have, very linear, straight up, straight down, you walk every aisle down. But again, this more fluidity that has been created, and it worked really well, that people, they came from the huge 10,000 people event and then walked into, after the lecture, and then walked into this marketplace. And yeah, it was really successful. So I will leave this as the first scent of generative design. Again, what my team has done to rethink or reimagine an experience. Mickey will talk more about this because it's a really fascinating topic. Because as we said, CAD is computer-aided design, but now we're really reaching the land of the computer designing for us. Not saying that it's going to take away all of our work. Humans are still necessary. You'll see why and how. But just as an idea, as a physical experience, what we did.
May I ask a question or afterwards?
Ja klar, nee, now, okay.
Do you need any data to fill into the system so that they, how does it work? So you decided to take bus and exposure, but how do you know which data you have to provide?
Yeah, excellent question. And Mickey's going to get into that a little bit more too. For us, because we had historical data, because we've done AU before, so we had also this intuition to know, okay, why do people go there? What do they want from it? What is really important? Then we had the floor plan. So it's almost the qualitative and the quantitative. So qualitatively, we know people, they want to see everything that's new. They want to get it as quickly as possible. They don't want to hunt for it because it's, I mean, we know Vegas is overwhelming. So how can we make it easy for them that they can see what's new in an easy way? So that was one data point. Then another data point, again, was how do we do the layout that they can get this, whoa, I can see everything at once. And then quantitatively as well is, this is our floor plan. This is how many exhibitors we have. This is how much space we have.
For the last few years too, Autodesk University had a mobile app. And in the last year or two, we also had RFID tracking, so we could actually tell where people were. And so there was a massive amount of actual data to work from in terms of where people flowed, where they flowed different days of the week, because it's almost a full week-long event with 10,000 people. How people went in ensembles. In other words, it wouldn't just be one person, but it might be the senior leadership plus some different teams, like from Jet Propulsion Lab or Airbus or some other things. And where would they be going and how they would flow. And so buzz versus exposure was just one of the ways that we explored it, but we could just click on different dimensions and be able to look at where a sweet spot was across high dimensions of things. Mm-hmm. And so you've got to kind of have both the ability for the architect to play around and the designer to play around and from what they've learned and use that sort of qualitative work and then also quantitative.
Yeah.
But great question. I mean, I think we glossed over that a little bit, but this turns out to be one of those things where humans are really bad at high dimensional problem solving. There's something called bounded rationality that if you read Herb Simon's book, you'll learn a little bit more about. He was a Nobel-winning economist. And humans tend to not be able to make choices beyond about 2 or 3. So because of bounded rationality, we tend to do what's called satisficing, which is that we don't sacrifice and we don't satisfy, we kind of find a balance. And it's just because cognitively it's very difficult. So this system allows you to kind of spawn 10,000 virtual interns that are all architectural interns or buzz interns or, you know, air conditioning interns who wander around the space and actually try out all the different goals. And it kind of works like Mendel's Peapod experiments. You spawn a whole bunch of them and they come back with how they solve things. And I'll show a little bit more about that in my part of the presentation.
Ah, yes, thank you.
Bounded
Thanks,
rationality,
Nikki.
good.
Excellent.
Yeah.
Alrighty. So this is from a person's view, just of what that experience then looked like when you were actually walking through it, so not the floor plan. Again, it worked out really well, but every year we're evolving it further. That's a new word, develop and evolve.
Well, and this year, because we were able to have all the RFID tracking and because we were able to see it, we had massive statistics about how this kind of a floor plan actually changed the dynamic, and that would feed back in to the design team as they were going to the next one. So this sort of built on a body of knowledge so that each one you could kind of learn how to start tweaking things each year.
Can I ask a question here?
Yeah.
So for the first time, basically the learning data was the experience of humans, right? What we had before, what worked. So that was kind of the learning data. Did you take that into consideration for the next generation, or was
always
tracking everything, the learning data for the next model?
Yeah, we could probably spend another hour talking about what's called generative learning, which uses machine learners to accelerate human learners. I don't think we'll have time today, but it's a massive new effort going on at Autodesk that actually builds learning into every tool. And we tracked hundreds of thousands of hours of people going to actual university classes at Autodesk University to get certified for different things. And those all feed back into the system as well.
Yeah.
Maybe put a little bookmark for generative learning, and we might be able to send you a few teasers.
Yeah. So let's continue with generative design for now. Handing over to Mickey. And this becomes interesting because cognition, you mentioned that before.
Yeah, I'm gonna actually stop sharing just for 1 second and start sharing again, just with a little slightly different trick, and see if I can get it to work. And let's see.
What are you tricking?
Oh, sometimes I can trick Zoom into actually not sucking so much in terms of where things are located. It's not doing it for me today. Oh, it's okay. All right, I'm just gonna hide your views so that I can see the slides and we can watch this. So I would make the case, and I think what Heike was setting up there was, we were talking about how design thinking is really a little bit more improvisational. I would say we're entering the age of sort of jazz in cognition itself, and not just machine cognition, sort of silicon cognition, where we talk about AI all the time, but actually human cognition as well. We're learning more in the last 10 years about how the brain really works as we're trying to build things like neural networks, and finding out that they're really poor examples of how the brain works. The brain is fairly amazing. And so I want to give you a sense of what I think the future design team or the future startup team is going to look like. You're going to have some learners that are human, and you're going to have some learners that are machines. And you're going to have some different things going on with each of those types of learners. If you think about human learners, we have prediction, we have common sense, we have creativity, we have passion. We also unfortunately have biases, but biases aren't always bad. If you think about like corduroy pants, you can slide your hand really slippery down one direction, but it's then kind of stiff the other direction. And that's a bias, right? Bias just is a slippery, it's like a shortcut. It's just that some of them are past their sell-by date. But humans have this amazing ability to continually run a model in their brain and think about predictions about what will happen. What will Mickey say next? What will Heike say next? How will we keep moving after this meeting, etc. We also have something called common sense, what I'll talk a little bit more about. Machine learners actually have commoditized prediction, and more recently, commoditized creativity. So this scares people because generating novel things is not just the purview of humans. If you look at something called generative adversarial networks, these are basically networks of machines fighting against each other to try to fool each other. They're creating novel, interesting new spaces. And in fact, generative design allows us to explore large surface areas of novelty. And they've also commoditized prediction. The reason we can have even a thought of self-driving cars is we can make a chip so cheap with some sensors to actually be able to try to predict, is that car going to pull out in front of us? So any industry that actually relies on prediction as their business model, or just creativity, human creativity alone, is probably under threat. But machine learners have a few problems. So machine learners have no common sense. When I say common sense, I'm kind of curious, what do people think about when I say common sense? What does common sense mean to any of you?
Things everyone agrees on, or everyone decides to agree, or history taught us makes sense for a lot of people.
Okay, anybody else?
Doesn't require an educated person to.
Might not be, yeah, might be just sort of built into the ether a little bit of us. What else?
Maybe it also comes with your culture, like patterns
That's right.
that you have seen.
Yeah, it has to do with this sort of, some people talk about it as wisdom. It is this sort of innateness that we kind of get. In machine learning, they say that machine learning systems have no innateness or no mental model. They don't have a model of the universe, and so they're actually very brittle. So I'll give you an example of how brittle they are. This is an adversarial patch. It looks kind of like a big old Silicon Valley. All the autonomous vehicles would blow through the stop sign because they would see a toaster on the side of the road, even if the sticker was about that big. And that's because machine learning is very brittle. It's based on training data. It doesn't have the ability to reason through analogy or metaphor. It can't leap across sort of notional spaces about things. It can't really understand common sense. And it doesn't actually have passion. You know, at this point, humans can't help themselves. We make crazy things like bad, ugly toasters and weird, shiny things and stuff, and we can't help ourselves.
Corduroy pants.
And corduroy pants. So I think if we do this right, we're going to end up with higher levels of cognitive diversity, because we'll be inviting in machine learning sets that have different points of view and also challenge us in different ways, and we'll have learners that are different points of view. BCG has put out a number of articles about the power of cognitive diversity to drive double-digit growth in revenue and profits and things. Just having people that think differently than you matters, and having structures that help you put people together in that way matters. Biases are also a real problem with machine learning. You just talked about that you visited some people yesterday about this. This is Joy Buolamwini out of MIT. She noticed that the best machine vision system in the world and the data set did not recognize her because she was African American. She had to go grab her roommate who was Asian American, and her roommate could be seen by the code she was writing. So she had to go out and buy a white face mask and wear that. So she's actually built something called the Algorithmic Justice League, because machine learning actually amplifies human biases, because that's the training data, right? If you pay women $2 or $2 for every $10 of a man, then that's the training data, especially if you did that for the last 10 years. So that's what the system is going to recommend to do in the future. So how do we play jazz with machines? And I want to give you a sense of what generative or generativity means when we say that word. If I just define two dimensions, if I just say what is on the inside of a snack and what is on the outside of a snack, immediately those two dimensions, just defining those two goals, starts to generate a whole bunch of things. Chocolate, peanut butter. Ooh, Reese's peanut butter cups. Chocolate, hot peppers. Oh, that's Mayan chocolate. Chocolate, chocolate. Ooh, it could be white chocolate, dark chocolate. Chocolate bacon. That sounds like a Chicago favorite, right? So very easy to do. Here's another one. You just define the vertical axis. In this case, it's what dimension do you bend to something? And you define the horizontal axis, which dimension do you cut something? And just by defining those two goals, you generate this massive explosion of things. It's kind of what happens when mom and dad get together and make you. That's a generative approach to things, basically. So here's an example of what generativity looks like in a design tool. This is in Fusion, which is available to everybody in the world as students and startups. And then, you know, it's a cloud product that you can pay for as well. And if you look at the middle, basically we just define how many newtons of forces, those are those arrows pointing down and pointing up, are on a truck. We just to say, look, there's a lot of forces here. We might have learned that through sensors. We might have learned that through just doing some math. And then we say, don't grow over here. Here's an obstacle. So one of my goals is that you support this much force. One of the obstacles or the boundaries is that there's a wheel that has to go there. So don't grow into the wheel, and don't grow into the skateboard below. And the system automatically generates 5 different approaches that are all manufacturable, basically intrinsically manufacturable. So it won't show you anything that can't be made either through subtractive or additive or casting or hybrid model. And so you can immediately iterate across things that a human would never have been able to come up with all these this quickly. And you focused on goals and constraints and problem sort of framing. Now, if you look at that in the context of taking a classic design, something existing, and then applying generative design to it, I can show you something like General Motors. They had something that had over 30 parts. This is just the thing that holds the seatbelts on. You can imagine all the sub-assemblies, and some of those things come from subcontractors. And that's a really important part. And General Motors has this mission of going to electronic vehicles and lightweighting things for better fuel efficiency. Now, if we looked at what happened, just by putting in those goals and constraints, the system ended up evolving something almost like form follows forces, that evolved to basically take the part of all 30 of those parts, and it iterated thousands of possibilities for this so that we could actually understand how much is undergoing stress, which one is going to be actually manufacturable, which one is going to actually be more supportable, where the wrenches will fit. In this case, this was for additively manufacturing with metal additives. Now, the curious thing is we went from 30 parts to 1 part. But when you look at the difference between the old part, which also had assembly time and the cost of that, you get to something that's 40% lighter, 20% stronger, and it's stored in the cloud. So you don't have, in the automotive world, 70% of spare parts are never used. They're just sitting in a factory forever because you have to like produce all of them. And then you can't reset the factory back to 2014 or something. So this just lives in the cloud. And then you just kind of print it on demand. And in fact, if you have sensors in there, you could kind of evolve it as you go. So that's a really nice example of that. And then I think to the question that was asked a little earlier about what kind of data do we use, it turns out the Internet of Things is cheap now, and we can start putting things into physical spaces. So not only the goals of the designer, the nature, the sort of DNA the designer puts in, but then how is it actually lived? How is it used? So I'll give you an example of that. This is a design for our research lab in Toronto, the Mars facility. And we had 2 years worth of training data from all sensors, and other things around meeting spaces and social spaces. We had goals like adjacency and work style and buzz and productivity. These are kind of tough ones, adjacency and work style, because they're human and what people think they want and what they really want are different. And we also had boundaries. We knew we had columns in the existing space. So over to the right, we had objectives. Some of those objectives were owned by the facility manager, some were owned by the research team, some were owned by the actual owner of the building. And then we had all the inputs, all the data. And then we spawned 10,000 virtual architects. And they wandered around through the space trying to reach those goals. And so one of the groups of interns that were virtual interns in the GPU space looked at work style preferences. They had little microphones and they could listen for acoustic levels. Some other ones actually did almost fluid dynamics on the buzz to look at where people stopped at the cooler to get, coffee or something like that. Then we had some others that were productivity interns. They wandered around with a little camera lens that looked out exactly at the visual and audio distractions for each desk and tried to optimize those for the different people and the different teams. We also know where Toronto is, so we can cast the sun. And we know that sunlight actually affects productivity. So we could actually put more people around it. Then we could even have little interns wandering around looking at what kind of views they'd get. Would they get cool views from the outside? So in this process, this developed a whole bunch, tens of thousands of possibilities. And then we had to do what Heike showed earlier. We had to pick sort of pairwise combinations. So we might look at all of these possibilities, but humans aren't great at looking at so many dimensions. And so we might look at something like, I don't know, buzz, as we talked about before, versus views to the outside. Or we might look at something like productivity versus views. Or we might look at daylight versus work style preferences. And in this process, we'd be able to like explore this. And so the intern said this felt like jazz. When they were sliding sliders and trying things, it would come up with crazy, stupid ideas, but they would explore a whole different area of music they'd never thought of because they were riffing on what the machine was coming up with. Last one I'll show in this is what happens when you take generative design and offsite construction.
Just want to make sure people are still there.
Is everyone still there?
Yes.
Yes.
Yeah, we're here.
So this is Van Wijnen in the Netherlands, and they had a goal of making net zero, which means that the communities basically don't consume any electricity or water. They capture their own water, they capture their own electricity, they do all that stuff. So net zero housing units. And they were interested in kind of what might be possible. And so some of those goals were owned by the owners, the people who would buy the houses, like the backyard size and the views. Some of them were owned by the general contractor, the cost and the profit. Some of them were owned by the city because the program and the variety matter to the city. They've got certain codes. And as we went through it, they were able to basically start looking at different permutations of these and then develop offsite manufacturing so they could have a lot more control over how they built these. By the end of the project, they were able to build a house every 3 days, and they had high margins, high profit margins, and high profitability, and happy customers who were able to do this. So if you know anything about construction and that sort of the world, margins are very low. And so this is kind of giving these contractors and these architects this power to actually have a little more control. And I think we should probably stop there. We've got like 5 minutes left in terms of questions and answers and things like that. But we thought we'd want to at least give you a taste of all the possibilities going on here.
Mm-hmm. And we know we didn't quite get to generative learning, but maybe we can have, I don't know what, another session at some time, maybe next year or so.
Yeah, and I think generative learning is taking the same idea, but then saying, how might you look at coming up with possible goals and constraints for your own career. And how might you use tacit knowledge and what's called dynamic formative assessment to actually try to prototype those possible goals.
How can I understand generative learning? Is it kind of learning like education, or is it learning like synthesizing information to take, I don't know, you have 3 data points and make 300 out of them by synthesizing?
Yeah, I'll give you a broad sense. So in a sense, generative design applied to learning, which is the work that I worked on and pioneered some of that work for the last 2 or 3 years at Autodesk, says that classically when you're learning something, we do something called summative assessment. We sort of come up with the list of what you will learn in the class, and then we sum it all up with a multi-choice test at the end. That means we capture the people who are kind of okay and can fit through it, but we lose the people who fall off a cliff because they got confused, and we lose the people who get bored at the top because basically you didn't move fast enough. And summative assessment has been largely proven to be a pretty broken methodology that was invented in the early 1900s. It's what a lot of educational systems are based on. The new approaches that we're starting to see have huge power are called dynamic formative assessment, in the moment. So as an example, if I make this glass in a design tool, I wonder how I would start. Does anybody know how you might start designing this glass if you just were looking at a blank page?
The goal
Yeah, what would a goal be for this glass? Anybody?
needs to hold.
It needs to hold water. Yeah.
Yeah,
So it
the
should
need.
probably be,
Like be cheap with material.
yeah, it could also be just that I want it to be, you know, so many centimeters this way by so many centimeters this way. I want it to be hollow at the top and this thick with a little chamfered edge. Well, when you're doing that, we can actually watch you do that. And we can say, wow, you just demonstrated that you knew how to do an extrusion and you knew how to actually extrude this and revolve it. We just watched you demonstrate being able to take the output of one tool and use it as the input for another tool, like milling it or building a tool. Wow, we just watched that. So we don't have to guess at whether you know something. Your ability to demonstrate in really doing things teaches us those things. If we had a little more time, I'd show you an example of
we
that
have
in
2
software,
minutes
but
for
we don't have time.
questions.
So I just want to.
We covered a lot. So we
Yeah.
did design thinking, origins, why it matters, that it's a process, that there's a lot to do in design, and then generative design. Yeah, so questions, observations.
Maybe you want to turn off
I have-
screen sharing so we can see everyone again.
Yeah, let's do
Yeah,
that.
okay. So I have a question that is more related to, I'm not sure if it is 100% more design, but more about like algorithm and what is happening in the tech industry. But since you guys are coming from the creative world, from the design world, how far away are we from the machines to actually start doing things that we cannot even imagine? What do I mean is that one thing is that 5 years ago, it wasn't mainstream that a machine could actually be creative. And then we realized that they can be even more creative than we are. So what would be the next step?
I think it's really important to remember back to that slide that I showed about common sense and passion. We are probably still a decade away from any machine learning system that has common sense or a mental model or innateness.
Okay.
If you'd like to read more about that, I'd look at like Gary Marcus and the work that he's doing. There are very big arguments about this, and there are also hundreds of millions of dollars of reward prizes from people like the Paul Allen Institute and others for any system that can show innateness and common sense. And so what happens is we see that robot dog do things that look an awful lot like it's a kind of scary thing, right? And human cognition is this giant pie with pattern recognition and analogy and all that. And because we see pattern recognition and because we see this kind of feedback loop there, we think that the dog has the whole pie, but it actually doesn't. It's missing a huge amount.
And
So, I mean, I think the point is we have to enable people and augment humans to be able to actually reach that farther self.
True.
Machines are going to do crazy things. I would worry more about the oops apocalypse, where basically just because machines work so fast, just like the flash crash in 2008 that took down a third of Wall Street, it was 2 algorithms fighting against each other with no circuit breaker, and they basically just destroyed the market. And I would worry more about the oops part of it because they don't have common sense, you know, but humans set these things up with very bad ability to have circuit breakers.
And I think in terms of possibilities or cognitive abilities, a machine is still, a 2-year-old human still has more potential, can do more than a machine, as we know right now.
Yeah.
Okay, sorry, it's 10. One more question, or do you have another session? Or do you have to go to dinner, wherever you are?
We
I
don't
have
have
a
another
question.
session. It's up to you guys.
Oh, we're okay.
We're
It's just
good.
up to you.
Yeah, yeah.
I have a question, if I may. Well, if you introduce such approach and such thinking into other organizations, I may assume that you have some resistances, probably from the middle management, because they think, oh, everything I did in the past was wrong. Now there come new guys with new, fresh ideas, so I'm useless right now, or I did everything wrong in the past, so I'm probably against this new idea because the machine cannot build my creativity and my passion that I put into the product. So how do you do this shift, or how do you accompany this cultural change, probably?
Well, you want
Well,
to?
I think, you know, so just having spent some time with the German company as well, and it is true that people have done their steps for 30 years or so, and they know it so well. Change management is scary, even to a point where if I used to, it takes me 60 steps to accomplish something, but I know it. I don't have to think about it. You know, the cognitive load is low. If it took me 3 steps and I would have to relearn it, we actually saw that people boycotted this, so that they'd rather do what they've done for 30 years than relearning. So change management is hugely important. And we saw at Autodesk as well, even at SAP, that when you can build the awareness, the understanding, and make sure that people actually would want to do it themselves, right? When it becomes also, I think, or it's just an example, virtual reality, I have to say a box in front of my face that even makes me sick, but augmented reality, when you can show the person that they're augmented with something and that they can choose to do this, and you're back to generative learning, when they make the choice. When, for example, you know, with bricklayers, when the robots come in and instead of them having to lift it and break their back, when the robot can give it to them, so when they can see the benefits themselves, then they will be more open to it, then they will embrace it. So slowly but surely, but you're completely right that it's very difficult. And, you know, we're threatened. We don't want to go there. So change management, I think, is super, super important for organization design, for learning, for training. And especially, I honestly, you know, within the German field or European, where I have reached a certain level of professionalism, of proficiency, and I don't want to be seen as, oh my God, I don't know anything, like you said. You don't want that. You want to build upon your expertise to know that you can grow further and not, holy God, now I'm falling down and now what, right? So
I think, yeah, I would say in some ways the middle manager is going to turn out to be more important than ever, because they're going to have to be dealing with humans that get bad training data and machines that get bad training data. And they've got to somehow translate whatever that senior leadership said into actually getting something going. And so I actually think, you know, in the agile world, right, we do something called Agile at Scale at BCG, where we help roll out to 6,000 or 8,000 employees a different way of looking at things. You see something very different. You see old middle managers are rewarded for headcount. Like, do I have 50 people reporting to me? Do I have 60? In the agile world, you're rewarded for growing leaders.
yes.
Well, that's very different. Like, are you actually growing leaders? Are you enabling them to be able to replace you so that you can go on and do something else? And I think that's why we decided to invest so much at Autodesk in generative learning, because if we can actually turn it into mastery, people love mastery. They love like feeling that fiero of kind of leveling up. You feel it in video games all the time, or if you golf or something like that. I did it, you know? And that's an endorphin rush. And if we can do that, and usually it's baby steps, it's like a little bit of a slippery slope. The thing is, good habits are formed by slippery slopes. You don't suddenly start losing weight. You don't suddenly have like a better way of dealing with your parents or your kid or whatever. You do little baby steps. And if we can give positive reinforcement through that process, then you can actually make it. Unfortunately, bad habits are also slippery slopes, right? You don't suddenly become a big drug dealer. You start out as an Olympic athlete, but then you realize everyone else seems to be running faster, and then you dope a little bit, and then pretty soon you figure out how to help the whole team. All true stories, by the way. So
From
these are
management.
things that have happened.
No.
But so I think it matters, but I think you're flagging exactly the right thing. If we use this big thing called AI and we say it's the panacea, you know, future of work, it's over. I think that's really naive. I think like Elon Musk doesn't understand humans. So if he goes to Mars, we should let him go.
Yes,
Shut the
please.
door.
Yeah.
Because humans are beautiful and crazy and amazing. And you, all of you, out-survived 3 billion years of a very competitive game to be here today, right? We have to remember 90% of life on Earth is extinct. So just the fact that you're here means you're a badass. And so are your kids. And I don't think we should cut that out. You know, our brains, in a sense, are surprise engines. We were made to cope with surprise. We may not like it. But I guarantee you, every one of us will remember this time more fondly than you know when you're older, because our brains are they're capable of this. And so there's plenty of work to do. We're never going to run out of work.
No. Another question.
Other questions, thoughts?
I have a couple of questions. The whole generative design approach reminds me of an architecture book called The Pattern Language. Do you know it?
Oh, no, you know what? Of course we do. I was thinking I have the other one, A Timeless Way of Building, right here. But yeah, Christopher Alexander did a wonderful job of kind of exploring this notion. And I will say what I noticed, Danil, who worked on that, he's an architect at The Living in New York, who worked on the Toronto project. Danil said when he first started doing generative design as an architect, you know, and he's an incredible architect, he said, well, I was kind of intimidated because I know what happens if I raise interns. Sometimes they go out and start their own design studio and they compete against me. So if I'm raising these like virtual interns, does that mean that's going to happen? But what he found was he could start playing around with different pattern languages. He could start playing around with different kind of goals and constraints. And it was so trivial to see 10,000 choices that would evolve out of that. And even the weird jazz, like tweaking of this one to this one, that it would have all these weird emergent things. Serendipity was kind of like accelerated. So I think what we're going to see is we're going to see some designers, architects, engineers, business leaders are going to embrace generative learning, generative design, and things like that. Some are going to be left behind because they just felt overwhelmed, and self-doubt is probably the #1 enemy of the world. And we're going to face a lot of self-doubt. So this was really interesting because the pattern language is an example, but I might want to say, do Christopher Alexander's pattern language for this building, do Kareem Rashid's, do Zaha Hadid's, and let's explore tweaking 20%, 50%. It's very much like a DJ.
Hey,
So how do we?
Mike and Mickey, can I ask you something? Because after this session, I will connect you all, so you will receive a short email with all the edits of everyone in the group. Can you maybe return with some book recommendations? Because I know this is always
Yes.
Always.
Let's start a book club.
Yeah.
Yes.
Jeffrey, I think you had a little second part to that question. I don't know if I answered the first part.
Well, how do we access these tools like the seatbelt holder? Like how can we use this?
If you go and sign up as a student for Fusion 360, because you're a student, you're learning, and Autodesk is happy to have people that are 80 years old learn. If you open,
not 80, we are.
I'm 80. But you can go look at Fusion, and then there's actually a new component called generative design, and it's in there, and you can check boxes and do it. It's a little geeky right now. Like it requires you to feel a little bit more like maybe a mechanical engineer or something. If you were an architect, you could use Revit, and Revit is another tool, and we've got something called Dynamo, which is a sort of generative language, and a brand new plugin for Dynamo and Revit called Refinery, which is basically generative design. It just went in beta the last few weeks for building, for physical spaces, campuses, and things like that. So it's possible to experiment now.
Great, thank you.
And I think even at the bottom level, I don't know if you've ever heard of Tinkercad.
Oh yeah.
But Tinkercad has about 10 million people that use it every month, and you just need a Chrome browser. That is a design tool that is an Autodesk design tool. But what's fascinating is when you design, you're not just designing with triangles and polygons and things like that. You're designing with real solid models, even though it looks like it's made for 6-year-olds and it's made for 60-year-olds, so I get to fit. But what's interesting is when you click send to Fusion, it sends a real parametric model, a real solid model to Fusion, so that you can put a screw in it and you can actually use it and things like that. So we've been trying to build these pathways from casual makers to being able to really mess around and then learn, because the learning really comes from messing around first, sort of hanging out and messing around, and then you geek out on something that you get excited by.
Heike and Mickey, thank you so much for this session. I really enjoyed it. I think you built it really nicely, good dramaturgy going into this crazy stuff of, I also like the presentation, the slides very much, kind of illustration.
Yeah, I appreciate you guys listening and taking the time.
Yeah, thank
This
you.
was fun. We don't get to do this very often as a tag team.
Well,
Are we going
I might
first?
knock on your doors again, because for me personally, I really enjoyed the session. Thank you so much.
Okay.
I've recorded the session. I'm going to share that with you as well.
Thank you.
And as I said before, you're going to be intro to everyone. So thank
Yeah,
you.
Thank you.
Have a wonderful day in San Francisco. All the best for the most of us.
Thank you.
All of us from Europe.
Have a lovely evening and good luck with the puppies. You're too far away. I can't take one off of you or two, Jeffrey.
All right.
Bye-bye.
Bye-bye.
Ciao. Cheers.
Okay.
Thank you.
Cheers. Bye.
Bye.